Welcome to topic number 22 in Richard James Mathematics Resources. This topic is entitled Construction. I hope that there is no one who intends to do something great without first making a plan. Plans come in many forms. A plan may just be a list of things written in a logical order. However, there are plans that require detailed scale drawings. Some drawings may be used by architects, engineers, and fashion designers. Can you imagine what all buildings, bridges, roads, and clothes would look like if every plan were comprised of straight lines and 90 degrees angles? Well, my great-great-grand-aunt had a proverb that says, "Jackass say the world no level." This means that things are not always going to be favorable, but it may also be interpreted in a physical sense. There are always going to be twists and turns and elevations and depressions that we will have to contend with in navigating through this world. Also, variety is the spice of life. Everything that we make cannot possibly have the same shape and size. Most things that we make use of are tangible, so they have to be designed and constructed. This topic is an introduction to the basic skills that may be used in designing all types of useful devices, vehicles, and edifices. As one advances in the subject and move on to other subjects to which mathematics is applicable, the skills that will be learned in this presentation will prove to be quite applicable. It will be very difficult to design a video that is three-dimensional without the use of a video camera. It is obvious that Richard James Mathematics Resources contain videos that are not live images of someone performing a task. The animations that must be done on a two-dimensional screen dictates that three-dimensional structures will be difficult to demonstrate and will also hide important details in a diagram. This limitation will affect the appearance of the pair of compasses, but with a little imagination, students will overcome this handicap. In this representation, the point of the compass will be represented by a little red circle. So that circle will represent the position of the point of the compass. The point of the pencil will be represented by a little blue triangle. So wherever you see that blue triangle, it represents the point of the pencil. The limitation may be converted to a great advantage because no significant portion of the diagrams will be hidden during the demonstration of the constructions. So while we are demonstrating the constructions, we will not have any hand on the screen to hide the diagram. So everything will be visible all at the same time. Construct number 1. Our first construct is the perpendicular bisector of the line AB. Our basis for doing this is that if we can locate 2 points that are equal distance from both A and B, the line through them will be the perpendicular bisector of AB. So anywhere we can find 2 points that are equal distances from A and B, then if we draw a line through those 2 points, that line will be the perpendicular bisector of the line AB. Notice that at the beginning, the point of the compass and the point of the pencil are both at the same location. This is not necessary. It is, however, necessary to begin by opening the pair of compass to more than half of the length of the line. So, open the pair of compass to more than half of the length of the line. By placing the compass point at A, or keeping it at that same location if it is already there, and without adjusting the pair of compass, make two arcs as shown. So, compass point at A, remember that the red circle, the little red circle that we have there, represents the position of the compass point. So the compass point is at A, and we are going to make two arcs. And of course, the demonstration of the two arcs will be right on the screen, where we see the movement of the little blue triangle, which of course represents the position of the point of the pencil. And what is the next thing that we do? Without adjusting the pair of compasses, place the compass point at B. So, do not open wider or cause it to go closer. So, don't change the position of the pencil, the point of the pencil and the point of the compass relative to each other. So, keep it at that. Make two other arcs. After placing the compass point at B, make two arcs. And of course, we are going to see how the two arcs will be drawn. Again, without adjusting the compass, that is, after we have drawn the first two arcs, without adjusting the compass, make another two arcs as shown. The straight line through the points of intersections of the arcs will be the perpendicular bisector of AB. There we have the line that goes through the intersection. So we have the arcs intersect there, and we have the intersection down there. That straight line that passes through them will be the perpendicular bisector of AB. Therefore, we can conclude that by using the compass in the way that we have just done, we have found 2 points. So this point is equal distance from A and B, and this point is equal distance from A and B. Any 2 points that we can locate that are equal distance from A and B, and we draw a line through them, we would have drawn the perpendicular bisector of AB. So, we are on to construct number 2, and of course 2A, because we have two different ways of doing it. In the previous construct, the perpendicular line was placed halfway between the points A and B. This time, the perpendicular line will be placed at one end of the line. It will be placed at A. The underlying principle will be the same. The only difference is that 2 points will be located in such a way that A is halfway between them. So, the perpendicular line needs to be, in this particular case, passing through the point A. So, in order to do that, what do we do first? In locating the two aforementioned points, first use a construction line to extend the line AB at the end where A is located. So right here, we are going to extend the line by using a pale construction line like we have it right there. Then what do we do? Next, place the compass point at A and make two arcs as shown. Make sure not to adjust the pair of compasses during the process. So, place the compass point at A and make two arcs just as we have them there. Right. So by doing that, what have we done? We have ensured that A is halfway between this point and this point. The 2 points, one of which is the intersection of the arc and the line AB, and the other is the intersection of the arc and the extension line, will be treated in the same way that we treated the points A and B in the previous construct. So, we have this point here, the point of intersection of the pier construction line and the arc, and we have this one, the point of intersection of this arc and the line AB. Now these 2 points, we are going to treat them in the same way that we treated the points AB in drawing the perpendicular bisector. So our 2 new points that we are going to be using in the construct will be these 2. We are going to use them instead of AB. Before continuing, the pair of compasses will have to be made a bit wider, or the arcs will meet at A, and the perpendicular line will not be easily drawn. So widen the compass a little bit. Place the compass point at the point of intersection of the line and the arc as shown, and draw other arcs as shown. So where are we going to put the compass point? We are going to put it at the first intersection right there, and we are going to make 2 other arcs. And do not forget that we made a little bit of adjustment to the compass after drawing the first 2 arcs. Next, place the compass point at the point of intersection of the arc and the line AB and make another pair of arcs as shown. So we are going to put it right there now, and we are going to make 2 other arcs. So the same setup that we did in the first construct, which is construct number 1, it is the same setup we have constructed right here. The only difference is that we have done some adjustment to the original diagram in such a way that the perpendicular line may be drawn now at A instead of being a bisector of the line AB. The straight line through the points of intersection of the arcs will be the perpendicular bisector of AB. Right. The construct would have been perfect without a second pair of arcs. That is, the lower pair of arcs or the upper pair of arcs may have been left out. Remember that we need 2 points that are equal distance from our 2 points, of which A is one of them. So we only need another one. Now remember now that if we are going to construct a perpendicular bisector of 2 points, it is going to be good enough to find 2 points that are equal distance from those points. And then the line through those points will form the perpendicular bisector. Now, if that is the case, we only need, say, this pair of arcs only, because the initial construct, which is drawing these 2 arcs, would have ensured already that A is equal distance between these 2. A is equal distance from this point and this point. And of course, this one that we have here is equal distance from this and this. Therefore, we are sure that if we draw this line through this point and this point alone, that we will have the perpendicular right at A. So this point is not necessary. Notice that in the accompanying booklet, only one set of arcs, the upper set, was drawn. This did not affect the construct in any way. So, of course, if you consult the accompanying notebook, you will realize that only one pair of arcs was drawn. However, with the inclusion of a lower set of arcs, we have confirmed that the construct is accurate by the line through both sets passing through A. So then, if we go ahead and include this pair and this pair, when we finish the construct, the line that passes through this and this, if it also passes through A, then that's a test to show that our construct is accurate. Now we are going to be taking a look at 2b, which is of course drawing a line that is perpendicular to AB, but that line is going to be drawn at A. So we have another version of the previous construct. The line is extended at A as before. So we're going to extend the line at A as we did before. Place the compass point at A as before, but this time make a semicircular arc as shown. So we are going to be approaching it in a different way. That is our semicircular arc. Place the compass point at the point of intersection of the pale construction line and the semicircular arc and make an arc as shown. So we have the pale construction line and the semicircular arc. The point of intersection is right here. Place the compass point right there and make another arc. Lovely. Move the point of the compass to the point of intersection of the line AB and the semicircular arc and make another arc as shown. So the point of intersection of the line AB and the semicircular arc right here, that is where we are going to place the point of the compass. And of course, we are going to make another arc. Good. Place the point of the compass at the point of intersection of one of the small arc and the semicircular arc and make another arc as shown. So this is the small arc, this is the semicircular arc. So we are going to put the compass point at the point of intersection of one of these small arcs, any one. Point of intersection of one of the small arcs with the semicircular arc. We're going to place it at one of them and we are going to make another arc. Just like we have it right there. Then, what do we imagine? We have not used this one as yet. There's no reason for drawing it if we're not going to be using it. And that's a rule of thumb when doing construction. So, move the point of the compass to the other point of intersection of the other small arc and the semicircular arc and make an arc as shown. Draw the line that goes from the final pair of arcs to the point A. This line will form a perpendicular at A. So, this is the final pair of arcs. Draw a line that goes straight through this and through A. And of course, that will cause the perpendicular to be at A. Very nice. There are two things that confuse students when learning to construct angles and shapes. The first one is where next to place the compass point in making an arc. Common sense should tell us that if we make arcs, there must be some logical reason for doing so, like we are going to use them to do something. Most times, the next step is to make use of the arc that we have just constructed in order to proceed. So, do not worry about how we progress. Make sure that you are always thinking about using some arc that you have constructed. The other one is where, that is the other concern, the other one is where did the instructor place the point of the compass while constructing a given arc or set of arcs? The answer lies in the curvature of the arcs. Remember that the arcs are really portions of circles. The compass point must be placed at a point that demonstrates the possible center of the circle. So then, if you don't know or you are at a loss, where could the compass point possibly be? Say for argument for this arc, if you don't know where to put the point of the compass, say you did not really see where the instructor or you just forgot, then you know that it is a part of a circle. This arc is a part of a circle. So where could the possible center of the circle be? Right here. So if the center of the circle is right here, there is no doubt that we could have a circle like that. What about this one? Where could we have placed the point of the compass? Could we have placed it here? No, because the curvature demonstrates that the point of the compass should be somewhere over here. And as a matter of fact, the only logical point of interest on this side would be right there. So that has to be where the compass point was placed. We will next construct a 60-degree angle. The basis for doing so is that if we can somehow construct a triangle with all sides equal, all angles will also be equal. With the knowledge that the sum of all angles in a triangle is equal to 180 degrees, dividing the sum equally among three angles will result in each being equal to 60 degrees. So that's it. Construct a 60 degrees angle. So in our mind, we are thinking to construct an equilateral triangle. Our duty is therefore to construct the frame of an equilateral triangle. We will begin by placing the compass point at A and making two arcs as shown. The two arcs have ensured that the distance from A to any point on the first arc is equal to the distance from A to the point of intersection of the line AB and the other arc. We need to complete our frame by ensuring that the distance between the point of intersection of the arcs and the point where the arcs cross B are equal. So, let us see exactly what that means. It means that by drawing these arcs here, we have accomplished two things. The distance from here to here is equal to the distance from here to somewhere, anywhere on this line. So anywhere on this arc that we put a point, the distance from here to here is equal to the distance from here to the point on this arc. But that's not going to be enough. We want to take a step that will cause the distance from here to up here, or wherever the point will be located, to be equal to the distance from here to here. So we are sure that the distance from here to here is equal to the distance from here to anywhere on this arc. But we need to locate that single point in such a way that the distance from here to here is equal to the distance from here to that particular point that is on this arc, and that is equal to the distance from here to here. So, without adjusting the compass, move the point of the compass to the point of intersection of the line AB and the arc. So, where the arc crosses the line AB, that's where we're going to put the compass point. The frame of the equilateral triangle will be completed by drawing another arc as shown. So, we are going to complete the frame by drawing this arc. So, without adjusting the compass, all of the arcs were drawn without adjusting the compass. Therefore, the distance from here to here is equal to the distance from here to here, and is equal to the distance from here to here. At the end, if we draw a line from here to here, the angle here will be 60 degrees. The angle here, if we do it like this, will be 60 degrees. And the angle up here will be 60 degrees. But we only need a single 60 degrees angle. If we were to complete the triangle, all of the angles would be equal to 60 degrees. However, we are only constructing a single 60 degree angle. Draw the line that goes from A to the intersection of the two arcs. Angle at A is therefore equal to 60 degrees. When constructing an angle, the construction line should indicate the size of the angle that is being constructed. That is, these construction lines that you have here will indicate the size of the angle that is being constructed. It is therefore not necessary to write the size of the angle in the diagram. Also, while the process seems to be flawless, the angle is sometimes not the exact value required. The difference may be negligible and the candidate may not be penalized, but it will not be truthful to say that it is actually 60 degrees. The size of the angle is best left out of the diagram, so let us leave it out. This fourth construct is a variation of 60 degrees. The 120 degrees angle may be constructed on the basis that if two angles are on a straight line and one is equal to 60 degrees, then the other is equal to 120 degrees. If the 120 degrees angle is to be constructed at the point B, the line at B should be extended as will be demonstrated in a short while. So, first extend the line at B by the use of a construction line. That's it. Do you remember our 60 degrees construct? With the compass point at B, make two arcs as shown. That is our same construct that we have used for our 60 degrees angle. Complete the frame of the equilateral triangle by moving the compass point to the point of intersection of the pale construction line and making a final arc as shown. So remember what we did? Move the compass point there, right, and make another arc, right. So that arc would have completed our construct, and draw the line from B to the point of intersection of the two arcs. The angle formed with this line and the extension line at B will be 60 degrees. Angles on a straight line will add to give 180 degrees. So if the one on this side of this line is 60 degrees, then what about the one on the other side? So the angle on the other side will therefore be equal to 120 degrees. So the one on the other side will be 120 degrees. And that is how we construct 120 degrees. By considering angles on a straight line, construct one to be 60, the other will be 120 degrees. Before moving on to the other two constructs, let us take a look at the principles involved in bisecting an angle. So, of course, you will imagine that the other two constructs will require that we bisect angles. Therefore, we are just going to demonstrate how we bisect an angle right here. Bisecting an angle is based on symmetry. The line that bisects an angle must be drawn in such a way that the portions of the diagram above and below it must be mirror images of each other. Right? So we are going to make a little structure, and the structure that we are going to make that structure in such a way that if we draw a line through it, that line that we draw through the structure will cause the structure to be divided into two halves that are mirror images of each other. That means whatever we are doing on one side of the mirror line, we'll have to do the opposite on the other side. So let us see what is going on. The two lines may not be equal in length, so it is not necessary for the two lines that form the angle to be equal in length. We will begin our symmetry by marking off sections that are equal in length then. Since it is not necessarily equal in length, we are going to mark off sections that are equal in length. So we are going to start our symmetry by doing that. By placing the compass point at the vertex and making two arcs as shown. So we are going to start our symmetry by marking off this and doing the same thing down here. And what do we know? we have started our symmetry by having from here to here is equal to the distance from here to here. We now need another point through which the line from the vertex will be drawn. So we want one more point. Bearing in mind that the portions of the diagram above and below the line should be mirror images of each other, the distance of the point from the points of intersection of the lines and the arcs must be equal. So any point that we are going to place anywhere here, that point must be equal distance from the intersection of the line and this arc and the intersection of this line and this arc. So this point that we'll have here must be equal distance from here and there. Right. We will proceed to draw two other arcs. The pair of compasses may be adjusted before drawing the first one, but not in the time between the construction of the two arcs. So we could have adjusted the compass at the beginning, but we could not adjust the compass when we are drawing the two arcs here. Then we may adjust the compass after that again, but we cannot adjust the compass while we are drawing the other two arcs. So we need to put the compass point at one of the intersections. Place the point of the compass at one point of intersection of one of the arcs and one of the line segments and make an arc as shown. So place the point of the compass at the point of intersection of one of the arcs and one of the line segments and make an arc as shown. So we are going to place it at the top one first, and then we are going to make an arc. Now we cannot adjust the compass in between. Move the point of the compass to the point of intersection of the other arc and the other line segment, and without further adjustment of the pair of compasses, make another arc as shown. Right. So then, by not adjusting the compass when we are drawing these two arcs, we are ensuring that this from here to here is equal from here to here. And then, when we are drawing these two arcs, we do not change the compass in between the time that we are drawing the two arcs again. That is to ensure that the distance from here to here is equal to the distance from here to here. The point of intersection of the last two arcs is equal distance from the point of intersection of the other arcs and their respective line segments. So this point is equal distance from here and there. The symmetry is completed, and the line that goes from the vertex to the last two arcs divides the angle into two equal angles. So that's our bisector of the angle, and that completes it. Therefore, in construct number 5, what are we going to do? In this exercise, we will construct a 30 degrees angle. This will be done by bisecting a 60 degrees angle. In examination conditions, the 60 degrees must also be constructed by making use of ruler and compasses only. The process is not strange to us at this stage. So the process of constructing a 60 degrees angle is not strange to us at this stage. However, in an examination, you will have to use just ruler and compasses only to construct that 60 degrees angle. And then use rulers and compasses only to bisect that angle. Let us construct the 60 degrees angle without much detailed description of the process. Remember that the pair of compasses should not be adjusted during the process. So, usual process to construct the 60 degrees angle, put the compass point at A and make two arcs as shown. Then, what do? We are going to move the point of the compass to where? Do we put it here or there? Well, apart from the fact that everybody should remember that it should be placed right here, we have to use common sense. If we have an arc right there, the most logical reason for drawing the arc is that we are going to use it to do something. So the most logical point to put the point of the compass will be right here. So let's see if that happens. Of course. And we make another arc. Right. Now we can complete the angle. Although it is not necessary to complete the angle, the 60 degrees, we have done that. We will complete the construction of the 30 degrees angle by bisecting the 60 degrees angle. Our aim is to construct the 30 degrees angle. The line that completes the 60 degree angle may not be necessary. The symmetry that is necessary to bisect the angle has been initiated by the first two arcs that were drawn with the compass point at A. So then, we are going to bisect this angle that we have right here at A. But the symmetry started already with this arc and this arc. Therefore, we don't really need this line because the point that we have right here is the point that is equal distance from here. We know that we have equal distance from A to the point and from A to right there. So we have the symmetry beginning already. We do not usually include unnecessary lines and arcs in a construction. We may therefore leave out the line that completes the 60 degrees angle. So we may leave that line out and continue with the symmetry. We may complete the symmetry that is necessary to bisect the angle by placing the compass point at the point of intersection of the two arcs that complete the 60 degrees angle and making an arc as shown. So we are going to put it right here and we are going to make an arc as shown. What are we going to do next? Move it to the point of intersection of the arc and the line AB. That's what we are going to do. So move the compass point to the point of intersection of the arc and the line AB and make a final arc as shown. The line that goes from the vertex at A to the point of intersection of the final arcs will bisect the 60 degrees angle, provided that the other line remained. So, if the other line was here, it would have a 60 degrees angle, and by drawing this, the 60 degrees angle would have been bisected. The angle formed is therefore equal to 30 degrees. So if you draw this line right here, then this angle is going to be 30 degrees because it would have been, this line that we have here would have been the bisector of the 60 degrees angle, providing that we had the line here. But not having that line there does not prevent this angle from being equal to 30 degrees. We need to construct a 45 degrees angle by bisecting a 90 degrees angle. We may choose any of the forms. Remember that we had two forms for the 90 degrees angle in the construction. So we may choose any of the forms of the construction of a perpendicular in obtaining our initial 90 degrees angle. The one presently on the screen does not provide us with an initial symmetry that is necessary to construct the bisector. So, although it is not impossible, we do not have an initial symmetry in this diagram that will allow us to get the 45 degrees angle. This is because the distance between A and the arc that is on the line AB, which is this arc here, is not equal to the distance from A to the point of intersection of any other pair of arcs. So the distance from here to here is not equal to the distance from here to here necessarily. Or the distance from here to here is not equal to the distance from here to here necessarily. Coincidentally, it might happen, but that is going to be a rare case. This does not, however, make it impossible to bisect the angle. The initial symmetry may be deliberately included, but it is not necessary because the other construct, which is the other construction of 90 degrees, has the initial symmetry necessary to bisect the angle. So let us use it. We can use this one and then start from scratch bisecting the angle. But the other one already has the initial symmetry that is required to bisect the angle. So let us use the other arrangement. Let us begin with the 90 degrees angle already constructed. The distance between A and the point of intersection of the semicircular arc and the line AB is equal to the distance between A and the point of intersection of the semicircular arc and the vertical line. Therefore, what we are saying is that the distance from here to here is equal to the distance from here to here. Why? Because the compass point was placed here in drawing this semicircular arc. Therefore, from here to here is a radius, and from here to here is also a radius. First, place the compass point at the point of intersection of the semicircular arc and the vertical line, which is right here, and make an arc as shown. Move the point of the compass to the point of intersection of the semicircular arc and the line AB. So this is where we're going to place it, and draw another arc. The line that goes from A to the point of intersection of the two arcs will bisect the 90 degrees angle. So that is 45 degrees, although it is not always good to indicate it in a diagram. Our next task is to construct a triangle with sides 10 centimeters, 8 centimeters, and 6 centimeters. So let us begin by drawing the longest line, which is 10 centimeters. With the aid of a ruler, draw a line 10 centimeters long, as shown. Of course, you know what that small triangle represents. That's the point of the pencil. So we draw that line 10 centimeters, which is of course 100 millimeters. So we have drawn that line. Place the point of the compass at the 0 centimeters mark on the ruler and adjust the pair of compasses in such a way that the point of the pencil is at the 8 centimeters mark, as shown. So we need to get the next line to be 8 centimeters in length. So we are going to place the point of the compass at the 0 mark and open the compass, placing the pencil at the 8 centimeters mark, and of course it is going to be indicated by 80 millimeters. So the compass point and the pencil point begin at the same location, and we are going to open the compass to 80 millimeters, which is 8 centimeters, and what do we do? Without adjusting the pair of compasses, place the point of the compass at one end of the line and make an arc as shown. So the compass point goes there, and we are going to make an arc without adjusting the compass. Good. So we have ensured that the distance from here to anywhere on this arc is 8 centimeters. So we need now to go to the other end of the line and get our 6 centimeters. So place the point of the compass at the 0 centimeter mark on the ruler and adjust the pair of compasses in such a way that the point of the pencil is at the 6 centimeters mark, as shown. So adjust it to the 6 centimeters mark. So we have done our duty with the 8 centimeters. We are going to do it with the 6 centimeters. Now what do we do? Without adjusting the pair of compasses, place the point of the compass at the other end of the line and make an arc as shown. So we are going to make an arc without adjusting the compass, put the compass point there and make another arc. So what have we done? We have ensured that the distance from here to any point on this line is 8 centimeters. And the distance from here to any point on this line is 6 centimeters. Therefore, if the two arcs cross here, the distance from here to here has to be 8, and the one from here to here has to be 6. The triangle may be successfully completed by drawing the lines from the ends of the first line to the point of intersection of the arcs. So you're going to draw from here to the point of intersection of the arcs, and from here to the point of intersection of the arcs. That's very nice, and we have completed the construct. Construct number 8. Our final construct requires a line that is parallel to AB and passes through the point C. The basis for doing this is that opposite sides of a parallelogram are equal in length. Without drawing the parallelogram completely, that is, if we can locate the missing vertex, then our task is complete. So we are going to look for the frame of a parallelogram. Bearing in mind that the opposite sides of a parallelogram are equal in length, let us first transfer the length of the side AC with the point B acting as a translation point of the point A. The first step in achieving this is to adjust the pair of compasses in such a way that the point of the compass is at the point A and the pencil is at the point C. So what is that really saying? We are going to transfer the length of the side AC. So now we are going to put in place the frame of a parallelogram. That means we have this single line here. We need to construct another line that is parallel to this somewhere up here. So we're going to transfer the line AC down here to making B the point of translation of the point A. So open the pair of compasses from A to C. Then we are going to move the point of the compass to B and make an arc. So without adjusting the pair of compasses, that is after we have opened from A to C, move the point of the compass to the point B and make an arc as shown. What does that cause? That causes the distance from A to C to be equal the distance from B to any point on this line. But we have to locate that single point by continuing our construct. To complete the parallelogram, the side AB must be transferred with the point C acting as a translation of the point A. So we are going to translate this line AB up here. So we have this same length from A to B up here. So we have done the first part by ensuring that the distance from A to C is the distance from B to somewhere along this arc. So to find that exact point, we need to get the distance AB to be equal to the distance from C to a point on this arc. So let us see what the information here is telling us. So we are going to translate this line AB, making C the translation of the point A. So what do? Open the compass with the point at A, the point of the compass at A, and the point of the pencil at B. Then what do? The vertex may be located by placing the point of the compass at C and making an arc as shown. Right. What we have done is that we have caused the distance from A to C to be equal to the distance from B to here, and also the distance from A to B to be equal to the distance from C to right there. So if we should complete the figure, we would get a parallelogram, and of course the opposite sides of a parallelogram are equal in length. So the AB is equal to the distance from C to there, and AC is equal to the distance from B to there. And that is a frame that we need to construct in order to draw the line that is what? Parallel to AB and passes through C. So by completing the quadrilateral, a parallelogram would be formed. However, this is not the aim of the exercise. We need the line that passes through C that is parallel to AB. The line may be drawn through C and the point of intersection of the two arcs. So that is all we need. We need a line that passes through C that is parallel to AB. But in order to do that, we constructed the frame of a parallelogram, because we know that this from here to here is going to be parallel to AB. So let us move merrily on to our exercises. The first one says, construct a parallelogram ABCD in which AB is 6.5 centimeters, AD is 5.7 centimeters, and angle BAD is equal to 60 degrees. Now, of course, our 60 degrees angle, we have constructed so many of them that we are quite familiar with that construct. Also, although we have not constructed 100 of them, the parallelogram is the last one that we have looked at. Although we did not really complete the parallelogram, but we really constructed the frame of the parallelogram. So this construct is something that we might be able to do with consummate ease. First, draw the line AB, which is equal to 6.5 centimeters. So we need to have AB 6.5 centimeters. Take our ruler, use the pencil. Of course, this is the point of the pencil that we have there, and we draw 6.5 centimeters. Then what do we do? Of course, that is AB, so one point at the end is A and the other is B. The angle BAD is 60 degrees. The middle letter is always the vertex at which the angle is located. So, if we have BAD, the angle is located at A. We will construct the 60 degrees at A by using our usual construct, the details of which will not be outlined here. Of course, we are not going to outline the detail, but of course it is going to be shown clearly what is taking place. Place the compass point at A and make an arc. Make another arc. So we make two arcs as shown to construct our 60 degrees. Can anybody remember what we will do next? Of course, put the compass point at the point of intersection of the arc and the line AB. And make another arc as shown. And of course, what do? Do we just draw the line? Well, we have the directives that the next line that we are going to draw, which is from A to D, is 5.7 centimeters. So what do? Go for our ruler again. The line that goes from A to D must be 5.7 centimeters. Draw the line in such a way that it goes from A through the point of intersection of the two arcs. So we're going to draw it like that. However, what do? We place our ruler right there and we draw that line by using our ruler. Draw it 5.7 centimeters. There's the point of our pencil. Let's go. Therefore, what do we do next? The angle that we have just constructed is BAD. We have the point A and B already. The point at the other end of a line that we have just drawn is therefore D. Lovely. Next, construct the line that passes through D and is parallel to and is equal in length to AB. So, the line that we are going to draw now is parallel to AB, passes through D. Remember, we have done a similar thing. Passes through C, parallel to AB. Now we're passing through D, parallel to AB. And of course, it is required to be the same length as AB. We will proceed as in construct number 8. First, open the pair of compass with the point at A and the point of the pencil at D. So we open the compass like that, and then what do? Place the point of the compass at B and make an arc as shown. So, by doing that, what are we ensuring? We are ensuring that the distance from A to D is equal to the distance from B to any point on this arc. So we need then to ensure that the distance from A to B is equal to the distance from B to the point on that arc. So we are going to do what next? Next, open the pair of compasses with the point at A and the point of the pencil at B. Then, without adjustment, place the point of the compass at D and make an arc. So open, then put the point of the compass at D and make an arc. What is the purpose of the final portion of the exercise that we have just done? By opening from A to B and putting the point of the compass at D, we are ensuring that the distance from A to B is equal to the distance from D to right there. The point of intersection of the arcs will be the final vertex C. The parallelogram may be completed by drawing the lines CD and BC. So there's your point C, and then we are going to have DC and BC. Very nice. Now, another exercise. Construct a quadrilateral ABCD with AB is equal to AD is equal to 6 centimeters and angle BAD is equal to 60 degrees. BC is equal to 4 centimeters and is perpendicular to AB. So, as we go along, we may dissect the question. First, draw the line AB is equal to 6 centimeters. Don't forget, AB is required to be 6 centimeters. So, from A to B, 6 centimeters. So, we use our ruler and put the pencil along it and draw 6 centimeters. That is AB. The angle BAD is 60 degrees. The middle letter is always the vertex at which the angle is located. We will construct the 60 degrees at A by using our usual construct, the details of which will not be outlined here. Of course, put the compass point at A and make 2 arcs as shown. So, we are constructing the 60 degrees angle for the umpteenth time. Good. Then what do? Just draw the line. The line that goes from A to D must be 6 centimeters. It says so right here. AB is equal to AD is equal to 6 centimeters. Draw the line in such a way that it goes from A through the point of intersection of the arcs. So, it should go from A to the point of intersection of the arcs. And of course, we are going to draw the line now, like that. Now, we could have saved a lot of time by bearing in mind that AB is equal to AD is 6 centimeters. So once we have drawn this line from here to here, 6 centimeters, what we do is open the compass to 6 centimeters, draw the arc. These two arcs would have been drawn 6 centimeters up, and then we come over here and draw the other arc. So by so doing, we would have eliminated the need to draw a line 6 centimeters at the end by using the ruler. So the ruler would not have been necessary in the end if we took that approach, because the construct would also ensure that the distance from here to here will be 6 centimeters also. The angle that we have just constructed is BAD. We have the point A and B already, so we need D. The point at the other end of the line that we have just drawn is therefore D. Remember the method of constructing a perpendicular at the end of a line. The process will not be carried out in details. However, the construction lines are shown. For details, consult construct number 2A. So we have right here the construction lines of the 90 degrees angle at B. Draw the line BC 4 centimeters long. The point C is at the end of the line. So from B to C along this line, because it says that what? BC 4 centimeters and is perpendicular to AB. So if BC is perpendicular to AB, this is AB, we need to construct a perpendicular here, and it goes from B to C. So take our ruler and draw the line. How? 4 centimeters long. Lovely. Remove both pencil and ruler so we can see. And then we are required to complete a quadrilateral. The quadrilateral will be completed by drawing the line CD. We needed a four-sided figure, a quadrilateral, and there it is. Construct triangle ABC with AB equal 9.5 centimeters. AC is equal to 7.5 centimeters. And angle BAC is 60 degrees. Locate the point D such that CD is parallel to AB and BD is perpendicular to AB. So that's a mouthful. First, draw the line AB 9.5 centimeters long. When you have a construction problem, do not try to construct everything after reading the question once. Take them step by step. Construct triangle ABC with AB is 9.5 centimeters. So join your 9.5 centimeters for AB. What do we do next? The angle BAC is 60 degrees. The middle letter is always the vertex at which the angle is located. So A is where it is located. We will construct the 60 degrees angle at A by using our usual construct, the details of which will not be outlined. So put the compass point there, and of course make two arcs as shown. Then place the compass point at the point of intersection of the line AB and the arc, and do what? Make another arc. The line that goes from A to C, which is AC, as we have it here, must be 7.5 centimeters. So draw the line in such a way that it goes from A through the point of intersection of the two arcs. So it must go from here to the point of intersection of the two arcs. And of course it has to be 7.5 centimeters long. And we have our pencil along the ruler and draw 7.5 centimeters. The angle that we have just constructed is BAC. We have the points A and B already. The point at the other end of the line that we have just drawn is therefore C. Good. But what did we have for our instruction? It says what? construct triangle. So complete triangle by joining B to C. We know that CD is parallel to AB. The required construct is similar to constructing a line through C that is parallel to AB. This will be our next construct. We will not know the exact location of D along the line until we observe where the perpendicular at B intersects the line. So what we are saying is that we are to locate D such that CD is parallel to AB. But after we have done with the construction of the parallel, that does not complete our work. We still will not know where D is. Now it says that BD is perpendicular to AB. So this is AB and BD is perpendicular to AB. So we are going to put another construct right there. So how do we construct our parallel? Do you remember? Try to get the distance AC to be translated by open the compass from A to C, then put the compass point at B and make an arc. Therefore, we know that the distance AC is the same as the distance from B to somewhere along this arc. But we need the parallel, so we have to do the frame of the parallelogram, complete that by opening the compass between A and B, putting the compass point at C, and make another arc. So we have ensured that the distance AB is the same as the distance from C to that point, and of course the distance from A to C is the same as from B to that point. So that line is our parallel, because we need to locate D in such a way that CD is parallel to AB. But where along this line will we find the point D? We take another tip. BD is perpendicular to AC. So BD is perpendicular to AB. So because AB is going to be perpendicular to the line that goes from B to D, we are going to put the perpendicular construct right there. So there it is. As usual, the perpendicular will be located at B, and the details of which are in 2A. So we are not going through the details of constructing the perpendicular at B right here. We are just going to include the construction lines. Now that we have a line that goes up like that, which is perpendicular to AB, and we have a line that goes straight across there that is parallel to AB, then we know that the point D is located right there. So the point D is a point of intersection of the two lines, which is right there, and we have located D.